Hello everyone. In this lesson, we will be learning free-falling objects. The best known constant acceleration example is gravity itself. Free-falling means a movement with constant acceleration towards down. Okay. Before modern science, people thought that the heavier the object was, the faster it fell. In 14th century, with Galileo's attentive observations, it provided that, without considering an object's masses, they travel with same acceleration downwards. With ignoring external effects, objects that are close to the surface accelerates with same ratio. A free-falling object's constant acceleration is called gravity and is shown as g. And we write the number for g in minus 9.8 meter over second square. Therefore, we write movement equations like this. So let's say that there is an object that has been thrown, and this right here is y0, this is y, v0, t0, and so a is minus g, right? Our velocity would be v0 minus g times t, and our position equation would be like this: y equals y0 plus v0t minus 1 over 2. Instead of at square, we will write gt square. And for our equation without using time, v square equals v0 square minus 2g y minus y0. So let's make an example about an object falling. A coin has been dropped from Empire State Building. Find its position and velocity at t equals 1, 2, and 3. So let's say that this is Empire State Building, okay? And a coin starting from here. Here, t equals 1, 2, and let's say 3. So its velocity at 0 is 0. And the second one, this is for t 1 seconds, v2, and this is for t 2 seconds, and v3 is for t 3 seconds. It's going downwards. Ay equals minus g, and that equals to minus 9.8 meter over second square. Okay, and now let's write one by one. How will it be for our position equations? For t 1 second, y equals y0 plus v0t minus 1 over 2 gt square, and that would equal to 0 plus 0 minus 1 over 2 9.8 t square, and that would equal to minus 4.9 meters. And for velocity, v equals v0 plus at, so it should equal to 0 minus 9.8 times t, and that should equal to minus 9.8 meter over second. And for t equals 2 seconds, again same, y0 plus v0t minus 1 over 2 at square. So this should equal to, again, 1 minus 1 over 2 9.8 t square, and this is equal to 19 0.6 meters, and for velocity, again, times t, minus 9.8 times 2, minus 19.6 meter over second. Lastly, for third second, y is equal to minus 1 over 2, 9.8 t square is equal to minus 44.1 meters. For velocity, minus 9.8 times 3, and that should equal to 29.4 meter over second. Okay. Now let's go to this third question. No, second question, I guess. Yes. So this one right here. A ball is thrown upwards with an initial velocity of 25 meter over second. So our ball is like this. An initial velocity 25 over second. How much time will it take to reach maximum height? What is its maximum height? What will be its velocity when it touches the ground? How much time will pass after it has been thrown and then hit to the ground? So, what has the question given to us? Y0 is 0, okay? And V0 is 25 meter over second. And our acceleration is minus g, okay? This is for t equals 1. And our equation that we will use is V0t plus 1 over 2 at squared. And that is v equals V0 plus 80. And this is becoming minus 1 over 2 gt squared, of course. We will write it. So, our graph for velocity and position would be like this. Just like this. This is for velocity and time, okay, and this is for time and position. So it will start from 0. As you know, it will go up, and as it reach the peak point, then will go down. So this right here will be our y max, and for this t second, let's make it capital T, okay. And for velocity, it will go up like with a fast velocity with v0, and it will slowly decrease, and after that hit the ground, just like this. So for A, T is equal to capital T, and Vt is equal to 0. Okay? And for A, how much time will it take to reach maximum height? Okay. So V equals to V0 plus AT, okay? And for Vt, it is V0 minus GT. And 0 is, why this is 0 at Vt? Because at right this point, it has no velocity. At that right moment, it has no velocity for just a matter of second. So we take this as 0, because it will stand in the air just like that, but it will continue. So for this point, we will take Vt as 0, and after that, again V0 minus GT. So T should equal to V0 over G, and that is equal to 25 meter over second over 9.8 meter over second squared. That is equal to 2.55 seconds. Okay, and now let's solve for B. What is its maximum height? Okay, its maximum height. So I think we have a lot of space to write, so I'm raising it. for b, v square is equal to v0 square plus 2a x minus x0. And for vt square, v0 square minus 2g, not instead of writing x because it's going upwards, we will write y max minus y0. And that should equal to 0 equals v0 square minus 2g y max minus 0. So y max will be equal to v0 square over 2g, and that is equal to 25 meter over second square over 2 times 9.8, and that is equal to 31.9 meters. And for c, v square is equal to v0 square minus 2g y minus y0. v2 should equal to v0. When it hits to the ground, we are taking these as 0 because it will have no height. Therefore, in root, v is equal to v0 square, so v is equal to 25 meter over second. And for d, y is equal y0 plus v0 t minus 1 over 3 gt square, and 0 equals to 0 plus v0 t minus 1 over 2 gt square. So t will be equal to tv 0 over g, and that equals to t 2t in a capital, and that is equal to 2 times 2.55 seconds, so it will take 5.1 seconds. So now let's move to other question. An engineer student runs